Energy powers the global economy. It heats your home, powers your lights, fuels your transportation, and has improved human conditions across the globe over the last 100 plus years. Demand has doubled over the last 40 years, and yet our thirst for it increases by the day. So where do we go from here, you ask? We're going to break it all down for you right now on UBS Trending. Hi, everybody, and welcome to UBS Trending. I'm Anthony Pastore. Thank you for joining us. Welcome to part one of a new limited series on a recent report out of our Chief Investment Office called The Energy Transition. And Jay Dobson, my colleague from the Chief Investment Office, one of the co-authors of that publication, is here with me today. Jay, good to have you here.
Oh, thanks for having me, Anthony.
This is not a new topic for us to discuss in this studio, Jay. We've been talking about energy and the energy transition for a while, but there's some new data in here and new recent information that you are all talking about and published. And so this is why we said, let's put together a series all about the energy transition and all the multiple facets of it. So today, when we look at the report, The Future of Energy, you can look at it and we talk about the growing demand of energy, which I don't think is a surprise to anybody watching this, but also the necessary focus on energy reliability, and also affordability, decarbonization, all those things. What's happening right now, and what have you discovered in your recent research here?
Yeah, it's really interesting. I mean, the whole report is focused on that changing energy landscape you're talking about. And I want to highlight what you said. Like, we've been writing about this for really the last 6 years or so. So this is the latest installment. But I think as we went through our analysis, sort of what we concluded was, the energy supply change continues, energy demand is growing, and quite frankly, this energy transition is becoming more complex, quite frankly, because of that growing demand. And something you just mentioned, I think, is important to reiterate. We've got a three-legged stool. It's decarbonization on one of those legs, but quite frankly, it's reliability and affordability on those other legs. The report is about 34 pages long. There's a ton of detail in there, but I'd say there were four main conclusions that, sort of we came away with. First, this transition is going to take a lot longer than people expect. The media wants you to believe we can sort of snap our fingers and do this. I think that'll be rather complicated. The second one is fossil fuels are going to be a significant part of the energy supply for an extended period of time. That's not to say efforts won't continue to reduce the concentration of fossil fuels, but they'll be a significant part of the energy supply for an extended period of time. I think really the third conclusion is we need an all-of-the-above approach. This isn't saying only clean or only dirty or only fossil fuels. This is all of the above, and I think what that opens up is tons of exciting opportunities in new technologies. And then the fourth conclusion really is there's regional differences. The report is actually called Energy Transitions purposefully, because I think when you look at Asia versus the United States versus Europe, you're going to see different transitions at different paces and, quite frankly, different priorities. But mix it all together, tons of opportunities for investors to invest in this energy transition.
Yeah, and I think you and I have talked about this many times, about that sort of misconception about, you call it the all-of-the-above approach, but people think clean energy means we're just going to stop using fossil fuels right away, but fossil fuels still make up something like, what, 80% of energy consumption? So with what you just started talking about there, that's the challenge, right? But there's also solutions in place. How do you put those together?
Yeah, well, I think the interesting thing is if we try and dig down a little bit, we can say 80% of the supply is fossil fuels. But quite frankly, if we look at a real-world example, Europe, when Russia invaded Ukraine, we actually burned more coal in that year. So the reality is it comes back to that sort of three-legged stool of decarbonization, affordability, and reliability, and that's going to be the transition. And I wouldn't want to mislead our viewers. The reality is, you burned more coal in that year. So we redoubled efforts globally, and people are working on ways to, continue to clean the energy supplies. But I think it's important real-world example to say this is going to happen in ebbs and flows. It's not going to be in this clean, straight line that we all want to sort of think in. It's going to be complex.
Right, and demand keeps increasing, not just because there might be more people driving cars or more shipping containers on trucks, but we're talking about AI as well. And it's been pretty well documented that AI, artificial intelligence, to run the databases within these data farms, it requires a lot of energy. So how is AI playing into the energy transitions that you're writing about?
Yeah, it drives energy demand. It's exactly what you said. But I think it's worth stepping back. So energy demand has continued to grow. When we look in the emerging markets, we look at population growth globally. We look at urbanization in developed and emerging markets. We look at the energy poor, quite frankly. This is an area I think gets ignored by, mass media a lot of times. But there are a lot of people that don't have electricity in their home, don't cook with clean cooking fuels. These are quite frankly, people that deserve that opportunity to have energy. You put that together with growing industrial demand for electricity, some reshoring into the industrialized world or the developed world, and you see growing demand for an extended period of time. Now, you mentioned AI. That's actually on top of that. And I think it's really significant. To put some numbers around it, if you look at one of these graphics processing units, the chips, GPUs that we're using in AI, one of those chips can use as much power, electricity, as an average US household.
Wow.
So you start sort of thinking how fast this is developed, and you look at certain of these chip manufacturers' sales, and you say, wow, significant number of chips, and it's significantly increasing. I would argue for these data center developers, power is sort of the new most important element that they need because it's very difficult to find.
Just incredible. When you paint the picture that specifically, how one chip is an entire home, it's unbelievable. And obviously we're going to need the all of the above approach as the demand for energy continues to increase. It certainly makes sense.
It's a great point because it's the complexity of the transition, I think. If we were in a sort of flat environment, demand wasn't growing, and we were just saying, well, we're going to substitute each molecule of oil or natural gas with X, wind, solar, battery, whatever, you could say, okay, and you could have some linear function that would tell you how long that would take. Now you're trying to, in a discrete period, not only change up existing supply, but meet new and growing demand. That, I think, is the biggest, hardest complexity of the energy transition. And again, underappreciated because this demand is accelerating, not decelerating, in part because of AI, but as well because of industrial reshoring.
It's really important to see those lines just continually go from right to left on the screen, just higher and higher and higher.
And it's interesting because when you look at that chart, I'm glad you put that back up there. The chart, the line that looks sort of flat is the developed world, and that's where most of the demand is. And then you see the bottom rising line, and that's the emerging markets driving the total amount. What you're about to see is that flatter line start to inflect upwards with industrial demand, AI. That's not to say it's not occurring in the emerging markets, but it's significantly concentrated in the developed world right now. So that's going to be interesting to watch because all those lines will be inflecting upwards further.
Visuals help. Here's another thing that let's go back to fossil fuels for a moment. And by the way, hopefully they can zoom in on this image that's behind us on the screen here. The team found a picture that really paints exactly what we're talking about, which is the fact that you can have an oil rig pumping oil out of the ground, but behind it just having wind farms producing wind energy, and probably somewhere in the background there's a solar farm out there happening as well. So all of these things can exist at the same time and need to, as you've said. So, but with fossil fuel, let's talk about, because there is a finite amount of fossil fuel in the ground around the Earth, right? So, I don't think we're in danger of it running out anytime soon, but it is finite. So talk about the importance, explain the fossil fuel aspect here and why it's still needed and still 80% of energy consumption.
Yeah, that's really the important point. Where the starting point we're at is fossil fuels on a global basis are about 80% of energy supplies. You have renewables, you have hydro, you have nuclear that makes up the balance of it. But the reality is that's 80%. So we're talking about replacing 80% of the global energy supply with something that is cleaner. That's a really tall order.
It's a big number.
It really is. And again, we're not just talking like some amorphous energy. We're talking about what drives the global economy and what, as we saw in Europe, people will change their decisions based on reliability and affordability. So it's not like you just sort of do this, swap one card for another. This is really complex. And again, it's not to minimize the impact of fossil fuels. Carbon dioxide in the atmosphere is an issue, but I think it is complex to say we're going to make this, very rapid change. That's why I think you really have to get people focused on all of the above. I think a lot of times policymakers and sometimes inadvertently even the media, we demonize one party or the other. And when I say party, I don't mean political party. I mean, the source of energy. And the reality is, we really need to embrace all of them. I've taken it to say it a different way that, thank God for renewables, quite frankly, because I'm not sure we could meet the, supply or demand for energy that we see right now without it.
Yeah.
And that's the reality. So I think, again, it comes back to complexity, all of the above, but a sheer recognition that, fossil fuels are 80% of current supply, and we can't change that quickly.
But have we seen this? I mean, you can look at history. We know that obviously fossil fuels weren't always driving energy. 100 years ago, we had coal and wood to coal and coal to oil. But when it comes to what we see today, have we seen it what have we seen before when it comes to those transitions that you're talking about?
Yeah, it's really interesting. I would call the sort of coal to oil and oil to natural gas as additive transitions. If you look at a chart of supplies, since 1850 or so, you can see that each of those new resources stack on top of an upward sloping line of those other or older supplies. I think the replacement transition hasn't really occurred. The closest we could come would be when the internal combustion engine, the automobile, replaced the horse. And if you go back in time, you can see people were really worried about horse manure and sort of disease that came out of that. And what are we going to do? And then lo and behold, the automobile came out of that. But the automobile was adopted largely on the basis of economics. It was a better technology, but economics drove the adoption. So that's the closest we can come, but it does inform me, at least, that economics are going to play a role here. People who say, hey, don't worry that it's more expensive, it's cleaner, I think that's going to be a tall order. The good part is, the United States and, quite frankly, the globe is really good about innovating, and we'll innovate around this problem. It may take 2 or 3 or 4 or 5 decades, but I'm confident that over an extended period of time, we can make great progress on cleaning up the global environment of carbon.
Yeah, it's funny you described the issues that were happening with horses. I mean, there were so many on streets and roads and whatever it was back then, but we don't think about today the issues that were arising because of, like you said, the disease that was coming. So we think, oh, it was just so perfect, but there's no such thing as a perfect solution. There's always some kind of a drawback. But clearly with technology, we're trying our best to mitigate emissions. We're trying to mitigate, obviously pollution and things like that. So more to come, I know, in this series we're going to talk about, Jay.
Yeah.
But before I let you go, and real quickly here, talk about the investment side of the story, especially with what we talked about today. Where's the investment case? What should investors be thinking about when it comes to this transition or these transitions over time within the energy landscape?
Yeah, I mean, you mentioned it as regional transitions, and I think that's the way to look at it. The good part is, as investors, we can go to a lot of different regions. So we can talk about it from an investment perspective as a global transition, and we can say, we expect that there'll be investments in the realm of $100 trillion by 2050. Now, that's all of the above. That's all sources of energy we'll need to meet existing supplies, new demand, and this sort of cleaner energy supply. When we got through the report, I think the near-term winners we saw were renewables, clearly, so solar and wind, natural gas, nuclear. It depends on where you are in the world, how nuclear is going to play. In Asia, it's probably new, large-scale facilities. It may be more like small modular, in the early 2030s here in the U.S. As we look out further, then you have carbon capture, you have hydrogen. As I was mentioning, nuclear is in both of those, nearer term and intermediate, longer term opportunities. So yeah, I'd say there's a lot of opportunities. And again, we're talking to a largely U.S. audience. We're same category. 80% of our supplies are sort of from fossil fuels. So innovation is here. I think there'll be a lot of opportunity for investment in this energy transition looking forward.
Excellent, Jay. More to this conversation, and just to remind our audience, we are going to be having multiple parts of this story over the coming weeks and months. But just getting us started today, Jay, thanks so much for doing that. Congrats on the report. There's a lot in there that we're going to talk about, again, as I said, over the next few weeks and months on this series. So good to see you, Jay Dobson.
Yeah,
Thanks for joining.
Thank you for the time.
Yeah, anytime. We'll see you soon. And thank you all for joining us. Lots of information available, of course, on our website, which is ubs.com/views. That comes out of our Chief Investment Office, including this Energy Transitions report. So make sure you're following the website, and then follow us also on social media. We're on all the major channels, including Instagram. You can follow the studio there at UBS Trending. And remember, continue this conversation with your financial advisor. Until next time, everybody, I'm Anthony Pastore. Have a great day, and remember to keep your eyes on what's trending. We'll see you soon.